Okay, let's check 10-6. You can use this like board practice where you do a problem, pause it, and then after you're finished, check to see how you did. Or if you already checked your work and you only need to see certain ones worked out, just fast forward to those problems. You don't have to watch the whole thing of this. So the top part says to find the sum of the measures of the interior angles. So remember from the notes, if you drew triangles inside from the same vertex, you drew triangles from the same vertex through the shape, you would have just two triangles in a quadrilateral. And so we came up with the formula that was whatever the number of sides were, if you minused 2, that would give you the number of triangles inside. So 4 minus 2 would be 2, and then you would have to times it by 180. Okay, so I'll just put in how many sides minus the 2 times the 180. So you'll have 2 times 180, and you'll get 360. This one would be 10 minus 2 times 180. And if you were plugging this all into a calculator, make sure that you subtract it with parentheses or subtract it in your head and then just times 180. So this one would be 1440, and there's the little degrees. If you end up doing this on a Google form quiz later, you're going to not use any labels like you would here. 12 gon just means there's 12 sides minus 2 times 180, so that's 100 degrees. A heptagon is 7 sides minus 2 times 180, that one is 900 degrees. Pentagon is 5 sides minus 2 times 180 degrees, and that's 540. A hexagon is 6 sides minus 2, because there would be 4 triangles, times 180 is 720. A 25 gon is 25 minus 2 times 180, and that would be 4,140 degrees. 100 gon would be 100 minus 2 in parentheses times 180, and you would get 17,640 degrees. Those are the sum. That gives you the total angle measures for those. Now, if you wanted each, you can only find each when they're regular because you need all of them to be the same so that you can divide by the number of sides to just find one. So these tell you the sum of all of them, but you don't know if they're regular where all sides are equal or not. These ones are telling you that all sides are equal. That means that all angles are equal. So when it says an interior angle, that just means 1. So when you only want 1, you do the exact same thing you did up top to figure out the total number for the angle measures, and then you have to divide it by the number of sides. So the regular nonagon, there would be 9 sides minus 2 times 180, and then you would have to divide it all by 2. So on the calculator, you could put 7 times 180 divided by 2 all at the same time, and it would be fine. But if you don't put parentheses around the 9 minus 2 and you type that into the calculator, it won't work. Regular octagon means 8 sides minus 2 times 180. Divide it by the number of sides, and over here I just realized I shouldn't have put 2. I get used to that divide by 2 with the triangles. You want to divide it by the number of sides. So that would have been divided by 9. Sorry, but the 140 is correct. This one here, each angle would be 135 degrees. The regular hexagon is 6 sides minus 2 times the 180, divide by the number of sides, and that comes out to 120 degrees. The regular 12 gon, you have 12 minus 2 times 180. You have to divide it by the number of sides. Every angle would be 150 degrees. A regular quadrilateral, like a square, not that you need to write this one out, but it would be 4 minus 2 times 180 degrees divided by the 4 sides. Surprise, surprise, you get 90 degrees in each regular quadrilateral, which is the same thing as a square. Regular decagon, that would be 10 minus 2 times 180, and then you're going to divide it by 10, and you're going to get 144 degrees. Down here, you don't have to name every single one, just what you see. So if you see a triangle, it doesn't matter where the triangle is that you see. Here's another one over here. You don't have to list all of them. What did you see? If you saw a triangle, put it. So you have triangles in there. If you see quadrilaterals, any four-sided shape, so any four-sided shape that you see would count as a quadrilateral. You don't have to specifically say squares or what kind of quadrilateral. You know, you don't have to say it's a rhombus. You can just say quadrilaterals for this one. When you see 1, 2, 3, 4, 5, 6, that would be hexagons. There's some hexagons in there. And if you see one with 8 sides, oh, there's an 8-sided one in there somewhere. 1, 2, 3, 4, 5, 6, 7, 8. That would be octagon. Okay, I don't know if there's anything else in there, but that looks good. This one, again, there are some triangles in here. There are some quadrilaterals. You could have put squares. That's fine if you were that specific about it. 1, 2, 3, 4, 5, 6, 7, 8 octagons. There's octagons in there. I mean, people could 2, 3, 4, 5, 6. You could put things together and say hexagons. I mean, you could if you started putting things together. So you could have more than that, or you could have just those. Or if you didn't see the hexagons by putting them together, that's okay too. Which of these is a regular? This one would be the one where all the sides are equal. These are all equal, but the angles inside aren't all equal because you have these small ones and then you have these concave ones. So like this and this are angles and they're completely different. So that's why it's not regular, because not only do the sides have to be equal, but so do the angles. And if you look at this one, this is a little smaller than that. So this is the only one that would be regular.